Hi guys, I am Muchakwa and again with Maths XYZ, and today we will be doing financial mathematics where we will be encountering two different interest rates in the period of the investment. Alright, here we have a question. In this type of question, I always encourage you guys to draw a timeline so that you will see in the timeline the change in interest rate that will happen during the period of investment. In this question here, it says in 1 year investment, in 1 year the investment grows to 3,606.02 cents. For the first 6 months, the interest rate is 9% per annum compounded monthly. After this, the interest rate changes to 12% per annum compounded quarterly. How much was the initial investment? Now that we know that our final investment here is 3,606.02 cents, that means that we have A and we are looking for P, which is the principal amount, the initial investment. Alright, as I told you guys to always draw a timeline with this so that you will always see the change in interest rates when you are dealing with this type of questions. I won't draw interest gain and I won't write a lot of information on it. I'll just show you guys that. Alright, let's take this, it's 1 year. This is our 1 year period, and they say for the first 6 months we have the interest rate, which is, we know that 1 year has 12 months, so that means the half of this 1 year we have 9% interest rate compounded monthly. Alright, so the first 6 months we have 9% interest rate compounded monthly, and that means that in 12 months, this is 12 months because this is half of the year, and it says continuing after this the interest rate changes to 12% per annum compounded quarterly. So now here we have 12% per annum compounded quarterly. Alright, then with the last 6 months we have only 2 quarters, since in a year we have 4 quarters, of which is the first 6 months, and the second half of the year we have 2 quarters. So here we have 2 quarters in a year quarterly. But then the first 6 months we know that is 9%, and the last 6 months, which is 12% compounded quarterly. All right, then it says we must find the initial investment, which is the principal amount. Okay, here we have A is equals to P into 1 plus I to the exponent of n. What we're looking for is P, of which will make it the subject to the formula, and have A is equals to 1 plus I to the exponent of n. Alright, and then after having this, guys, what we need to do here, having different interest rate, what we need to do, because we have 2 different interest rate, that means that we have to have 2 of this, 1 plus I to the exponent of n and 1 plus I to the exponent of n. So if it changed more than 2 times, if it was 3 times, then we're gonna have 3 of the same of the same equation. Then here we have A, which is our principal, which is our final amount, which is 3,606.02 divided by 1 plus our interest rate for the first month. It was 9% compounded monthly, so this is 9% divided by 12. Remember, if it's compounded monthly, then it's divided by 12%. And then now that is what it was for the first 6 months, that means that the period is 6 months there. Alright, and then going forward, the interest rate changes to 12%, and it was compounded quarterly. That means that we have to divide by 4, and then the period this investment will only stay for 2 quarters, because remember that in the last 6 months of the year, that means that it's only 2 quarters in a year. I need you guys to understand something, that we divided by 12. Reason being, it's compounded monthly, and then we multiply, the exponent is equals to 6, not 12. Reason being, it was only there for 12 months, not for 6 months, I mean to say, not 12 months. Then it changed to be the quarter, which is 4, and then there we have 2, which is equals to, in a 6 months period we only have 2 quarters, so that that period is only 2 quarters. Alright, from here now, that's when we just use a calculator, which is 3,606.02 divided by 1 plus, okay, 9% divided by 12 to an exponent of 6. Alright, and then multiply again with 1 plus 12% to divide by 4 to an exponent of 2. Then this gives us 3,449, 3,249,99, which we can just assume that the initial investment was actually 3,250. This was the initial investment. But I hope you guys understood this question, that with the different interest rate, what you need to do is to multiply those two brackets together. If it changes twice, then you have to have 2 of that. But if it changes 3 times, then you will have 3 of those. And then always remember that with the period and also the interest rate, it's not necessarily that when you divide by 12, if it's compounded monthly, then you also have 12 there. No, it depends on how many months was it there in the account. For this case here, it was only there for a 6 month, because this investment only took a year. And then on this case, we divide by 4 because it's compounded quarterly. The investment will actually be calculated in a quarter. And then for the period, it was only in the account for only 2 quarters. Reason being, it was the last 6 months of or in a year. Alright guys, I hope you understand this question. So let's just move to the second question. Let's just move to the second question, where we will be looking at Mpo. We'll be looking at Mpo, who invested 3,000 into a savings account at an interest rate of 5.5% per annum, compounded monthly. After 3 years, the interest rate drops to 3.25% per annum, compounded monthly. How much will she have after a period of 5 years? So we still use the very same equation, where A is equals to P into 1 plus I to the exponent of n. And then this time she invested 3,000 into a savings account at an interest rate of 5.5% compounded monthly. And then after 3 years, the interest rate drops to 3.25. So it only changed twice. So we'll have 2 of those. Alright, this is one, this is the second one. We don't touch P. Alright, then we have P, which is 3,000 in this case, into 1 plus our I. The first one, it was 5%, which is compounded monthly. That means that it will be 12. And then this, it only stayed for, remember they say we must calculate after 5 years, and it changed after 3 years. That means that here we have 3 multiplied by 12. Okay, and then I'll just erase this side. I'll just erase this line, guys, so that I don't write at the second line. So here it will also multiply again with this one, which is 1 plus our interest rate. When it dropped to 3.25%. All right, then this will also be divided by 12 because it's compounded monthly. And then to the exponent of, we're calculating in a period of 5 years. The first one only took 3 years, and the second one, that only means that it will take 2 years. So this will be 2 multiplied by 12. Alright, and then this will just punch into a calculator, and they will have our answer. So it's 3,000 here into 1 plus 5.5 divided by 12 to the exponent of 3 multiplied by 12, which is 36, guys. And then also multiply again with 1 plus 3.25% divided by 12 to the exponent of 2 multiplied by 12, which is also 24. Alright, so I will just write 24 instead. Then here we have, oh god, what did I do? It's actually giving me a very huge number. It's giving me a very huge number here. Okay, I see what the mistake is. Okay, that was 5%. Then here the investment is actually 3,774,04. Okay, that's 0.05 cents. So after a period of 5 years, if the first interest rate for the first 3 years, it was 5.5%, and the interest rate after 3 years drops to 3.25, which will only be for 2 years, then the investment will be worth 3,774. That means that in a period of 5 years, this person would only have gained 3,774.05 cents in 5 years. We can't really say it's a good investment, but it's actually not much, because in 5 years period, 700 is not a lot of money. Alright guys. guys, thank you very much for tuning in this lesson. And if you have any question, please just drop us a note, and then we will have a comment on it. And also guys, don't forget to subscribe to Maths XYZ channel on YouTube, so that you will be able to get notification when we upload videos. Thank you.